Most of what you've been told about healthy eating is based on 50-year-old myths and really bad science. So today, we're starting over. 10 foods that your body genuinely needs, not because a food pyramid says so, but because of what they actually do inside your cells. Hello, health champions. Here are 10 foods that you need in your diet based on what your body actually needs. So here's basically how we've been told to eat for the last 50 years. This is the politically correct way of eating. But what I want to talk about is why different food groups help us or don't help us. And the two groups that marked in red that we want to focus on, the three groups where I put a question mark, which are groups that we want to have some, but we want to understand what versions of that we want to have. And the base of the traditional pyramid, which is grains and rice and cereal, etc., which is not something that we need. Some people can tolerate it, but it has no real value to us. And we're going to talk about these foods in no particular order because no one food has any magical properties that are going to solve everything for you. A lot of people have that mindset, but that mindset sends you off in the wrong direction. Also, variety supports different systems and foods are complementary. And the first one we want to talk about is fermented foods. And we start with fermented dairy. And fermentation is mankind's oldest form of preservation. And not just does it preserve it, but in case of yogurt and kefir, which are two dairy products that have been fermented, what they provide is probiotics. And that means that they have live bacterial species that can seed and diversify the bacterial flora that we have in our guts. And we'll come back and talk about why that's important. And the main things we get from yogurt are lactobacillus and bifidobacterium. And there's different strains of these, so we get like half a dozen. And they compete with and they inhibit the bacteria that we don't want, the pathogenic, opportunistic bacteria that create toxins and disease. And some of these bacteria that we want are colonizers, meaning they set up shop and they live there almost indefinitely. And others just kind of pass through, but in doing that, they can still provide benefit because they still compete and inhibit some of those pathogens. And then kefir is just another version which has a lot more different species, different types of bacteria. So it adds complexity and it also adds some beneficial yeasts that yogurt doesn't have. And because it has more complexity and more strains, there's also going to be more colonizers, more potential to have beneficial strains set up shop. And I would recommend that you make your own. Do a little research, buy yourself a little yogurt machine, and then you start off, either you could buy the bacteria or you could just buy a yogurt or a kefir that you really like, and then you just take a couple of tablespoons of that, you add your own dairy and you put it in the machine and then you run it from there. Because in doing your own, you can let the machine run for much, much longer. I run my yogurt for 48 to 60 hours and it gets much more sour and I get much more of the beneficial bacteria. Plus, they eat up all the lactose, so there's very, very little sugar left. But we can also ferment vegetables. And the traditional ones are fermented cabbage, which is sauerkraut in Europe and the US, and kimchi in Asia. But pretty much any vegetable can be fermented. So carrots, beets, cucumbers, green beans, etc. You can ferment all of those. And there's lots and lots of guidance on the internet on how to do that. Just don't confuse it with pickling because that's something different. Pickling does not provide any beneficial bacteria. It's just a preservation method. And just like with the yogurt and kefir, you're getting probiotics, meaning live bacteria. But here you're also, with vegetables, you're getting prebiotics, which is fiber and polyphenols, which acts as food for existing bacteria and for these live bacteria that you're consuming. So we have prebiotics and probiotics, but then because we're feeding these bacteria, they're also producing things, and those are called postbiotics. And all of these are super important. We don't want to just take probiotics because that doesn't contribute to the whole environment, not enough. But with postbiotics, now the bacteria are making things like short-chain fatty acids. There's several different kinds, but the one that's most notable is butyric acid, butyrate. And what this does is it feeds a lot of the cells in the gut. It feeds other beneficial bacteria, but it's also fuel for the enterocytes, for the cells that line our gut and keep that tight. So therefore, it prevents the LPS, lipopolysaccharides. Those are toxic byproducts of pathogenic bacteria. And if our enterocytes are not healthy, now we're going to have a leaky gut, and these LPSs are going to leak out and basically poison your system. They're going to create inflammation, and they can also contribute to anxiety and depression. But if this whole system is working and we get this butyrate produced, then we're going to maintain the tight junctions, and we're going to protect the lining and maintain gut integrity. And also, fermentation actually pre-digests a lot of the anti-nutrients, a lot of the things that people are sensitive to in plants like phytates and lectins. Once we ferment them, a lot of that stuff goes away. But here's the main point of what I want to talk to you today about, is that when we talk about healthy foods, when we talk about diet and what the body needs, we need to realize that there are two different systems that we need to feed. And that's why I started off with the fermented foods and the bacteria. So we have 30 trillion cells, give or take, in the human body. But out of those, the vast majority, about 25 trillion, are red blood cells. And they have limited biological activity. They're super important, they carry oxygen, but they don't have any nucleus. They don't actually produce anything, no new proteins or any new building blocks or anything like that. So we really have 5 trillion cells that have a nucleus, that are like little machines. And we want to compare and contrast that to the 40 trillion gut bacteria that we have in our microbiome. So that's about 8 times more cells in the body that we have in the gut that are actually metabolically active in the sense that they manufacture things. But then what's even more interesting to really show you the scope of this is that these gut bacteria, between them, have about 150 times more different DNA in the gut than we have in our human cells. So we want to start thinking of this, that you have your human genome, that your human DNA, that's like your first genome, but then in the gut, you have a complete second genome that is actually much larger. So we want to think about these as two completely different universes, two completely different ecosystems. We have the human and we have the gut. And they're separate but complementary. And what we need to understand that in terms of feeding, they have very, very different needs. So when it comes to humans, we want to talk about feeding the protein, fat, vitamins, and minerals. That's kind of the usual stuff that we talk about, even though we get it backwards a lot. But with the gut, which is equally important to feed, we're talking about fermentable fiber that really does nothing for the human. We want to talk about polyphenols that can actually be bad for humans if we don't have the bacteria to break it down, and also some resistant starch. And I'm not going to talk about that real heavily today, but resistant starch is a real thing. It is something that can feed your gut bacteria in certain aspects, in certain ways that other fiber and polyphenols can't. So when we talk about foods that your body needs, we need to cover both systems, and we can't starve either system. So for foods 1 through 4, we're going to talk about feeding the gut. And while these foods do have some vitamins and minerals, they have very low caloric value. and they mostly contain fiber and polyphenols. Food 5 and 6 are a couple of foods that have value for both systems, both the gut biome and the human feeding. And then for the last 4 foods, food 7 through 10, or groupings of food, that is about feeding the human. And now we're talking about the traditional foods, the protein and the fat, which has high caloric value. And we're talking about saturated fatty acids, monounsaturated fatty acids, essential fatty acids, essential amino acids, and of course more vitamins and minerals. And this food has very high survival value. It's very nutrient dense. So with food number 2, we're still talking about feeding the gut, and that's cruciferous vegetables. So here are broccoli or broccoli sprouts, Brussels sprouts, cabbage, cauliflower, and arugula are examples of cruciferous vegetables. And what they contain, among other things, is something called sulforaphane. And this is a chemical compound that activates what's called NRF2, which is kind of a master switch for your body's cleanup defenses. So this master switch will turn on glutathione and catalase and superoxide dismutase, which are your body's antioxidants and cleanup crew. And I know you've heard a lot about antioxidants, and you heard that fruits and vegetables are good because you get a bunch of antioxidants. But when we talk about this switch and what it turns on, then dietary antioxidants don't even come close. They're not in the same universe of comparison. They're negligible in comparison. So vitamin C, for example, it can donate 2 electrons and neutralize a free radical. Then it's done. Then it has to be recycled or done something else with. Whereas, for example, this catalase, it's an enzyme, and it will neutralize 6 million free radicals per minute and keep going. So when we talk about antioxidants, we really need to understand that we need to get them from inside the body, the stuff that we produce. And the cruciferous vegetables also have fermentable fiber, which we talked about. The body can turn into butyrate and support the gut. And it has also some support for mucus formation, which is further gut support, which creates a protective lining inside the gut. Food number 3 to support gut is leafy greens. And we have things like romaine, green lettuce, arugula, kale, Swiss chard. Anything green and leafy is a leafy green, just like the name says. And I want to mention spinach because it's a very popular leafy green with some people, whereas others can't tolerate it because it's very high in oxalates, which can be irritating and form kidney stones, etc. However, the reason this is so individual depends on your gut health. And you could be having a leaky gut that creates a huge problem because now these oxalates leak out. Or if you're really low in certain bacteria like Oxalobacter species that actually consume and break down the oxalates. Leafy greens are high in magnesium typically, and magnesium is something that most people are deficient in. It's almost like a universal deficiency, and yet magnesium supports more than 300 enzymatic reactions. And some of the most important ones are ATP, making energy, DNA repair depends on magnesium, and also membrane potential. So your nervous system, your brain cells, your nerve cells, they have certain electrical potential. And magnesium helps balance and regulate and suppress that membrane potential a little bit so that these cells don't become overactive and erratic. That's why magnesium is often called calming. And magnesium is something that you would want to consider supplementing because most people are deficient due to soil depletions. The soil doesn't have nearly the amount of magnesium that it used to. And also, refined carb consumption will interfere with the absorption of magnesium. Leafy greens also contain dietary nitrate, which when we expose this to acid hopefully you have some stomach acid, then that turns into nitric oxide, which is a vasodilator that helps the body regulate vasodilation and circulation. So if we can increase that, we can increase and have a better circulation overall. Food number 4 is berries. And here I like the blackberries, blueberries, raspberries, and strawberries. And why I prefer those? Because they are generally low in sugar, high in fiber, and high in polyphenols. And again, the fiber and polyphenols are to feed your bacteria. They're food for your gut environment. And one thing specifically they contain is called anthocyanins, which is the pigment or the color that give these berries their deep, strong color. Now, these anthocyanins, they're very poorly absorbed, and this is by design because you're not supposed to absorb them. They're not for your human cells. They don't do any good in the bloodstream. They do their work in the gut. And when they're poorly absorbed, now they travel intact or untouched all the way to the end, to the colon. And here they are used to feed specific bacteria that are very picky in their taste. And now they become bioactive compounds and they help to modulate the biome composition. So they help to bring up some of the species that we need, and they help suppress some of the species that we don't. And one specific thing that they contribute, that they support, is called akkermansia. And akkermansia is something that produces mucus and helps to build a stronger protective mucus layer. And it's not just about protection. We don't even understand all these things that they do yet, but what they have found is that akkermansia is consistently low, consistently deficient in people with insulin resistant, with obesity, and inflammatory bowel disease. And again, we don't understand all the things, all the reasons why it works this way, but we do know that the gut health and the biome composition has a lot to do with metabolic signaling that contribute to these health problems. Number 5 is avocado, olives, and extra virgin olive oil. So even though they don't taste sweet, these are actually fruits, and they are low carb, high fat fruits that we can make oil from very, very easily. So that makes them healthy oil because we don't have to expose them to massive heat and pressure and chemicals. And this food is kind of in the middle. It's like a transition in terms of what we're talking about. It can feed both these universes, both the human cells and the microbiome. And both avocado and olives have over 70% of the fat in there is monounsaturated fatty acids. And what this fat does is it activates something called PPAR-alpha, which helps us increase fat burning. It stimulates certain processes that increase fat utilization and decreases inflammation. And avocado is something that's very high in potassium. It has like twice as much potassium as bananas, which people often bring up as the textbook example. And it's also very high in fiber. And we've talked about how that feeds the gut bacteria. Also, the polyphenols in avocado are strongly prebiotic, that they serve as an excellent source of food for these bacteria. And then olives and olive oil contain something called oleocanthal, which will decrease the expression of something called COX-1 and COX-2, which are inflammatory messengers. So in other words, the oleocanthal in olives will actually reduce inflammation. And very interestingly, this is the same mechanism as ibuprofen. That's what ibuprofen does. It suppresses COX-1 and COX-2. So here you have a natural method that you can do it without any side effects. And number 6 is nuts and seeds. And here we have things with fiber and polyphenols. And these, again, are strongly prebiotic. They're strongly supporting the gut bacteria with food. They do contain some vitamins and minerals, And we're going to talk about specifically like the advantages and potential problems with different types. So walnuts, almonds, macadamia, and pecans are some excellent nuts because they're high in good fats and they're low in carbohydrates. And some seeds, we'll talk about pumpkin, flaxseed, and chia seeds. So when it comes to walnuts, it has a number of different ways that it supports the brain and the microbiome. And the brain support is not because it has some omega-3s, it's because of signaling properties. That gets pretty complicated and I don't want to get into that. The problem though with walnuts is that some nuts and seeds can provide a little bit too much of omega-6. So walnuts has tremendous benefits both for brain and biome signaling. However, it is high in omega-6. So we don't want to think of these as something, oh, this is the best, let me eat tons of that. Almonds contain the best prebiotic fiber, but almonds also has something called lectins, which can be strongly irritable for a lot of people. Now, the lectins are primarily in the brown skin. So if you eat blanched almonds, that problem goes away. Still, you don't want to overdo any of these because a lot of people who go low carb and they give up bread and starch, now they find recipes and all they talk about is almond flour. So now they start baking. And as soon as you overdo something, there's a high risk that you develop a sensitivity. So just eat a little bit of all of them. Macadamia nuts are the highest in fat. They're the highest in monounsaturated fats like avocado and olive oil. And they're the lowest in omega-6, which is the inflammatory component. When it gets too high, it becomes a pro-inflammatory component. We have pecans that are also very, very high, almost as high in monounsaturated fats. And they're also very low in omega-6 and carbohydrates. Pumpkin seed is a little nutrient package. It's very high in protein. It's one of the best sources we have for magnesium and zinc. But the problem is it is kind of high. It's sort of in the middle when it comes to omega-6s. So again, you don't want to overeat these things. Don't think of them as a food group, just a good thing to add in here and there. And then we have two interesting seeds called flax and chia. They're very similar, except flax we have to grind up before we consume it because we can't break down the shell. They're very low in carb and they have a very favorable ratio of omega-6 to omega-3. They're very high in omega-3, both of them. And most people have a severe dominance of omega-6, like 15 to 20 times as much omega-6 as omega-3 in their cell membranes and in their tissues. So by eating something that has basically the opposite ratio, it's not as much as 15 or 20 times, but it has a lot more omega-3 than omega-6, now we help offset that. And of course, the fiber also serves as a prebiotic and helps gut motility as well. But I do want to mention the biggest risk with nuts and seeds is if you start doing smoothies and you mix in like half a cup a day, now you can absolutely risk getting excess omega-6. And this is whether you use the oil or the seed in cooking or in smoothies. So I want to just list these out for you so you know. Walnut and sunflower seed, safflower seed, pine nuts, a lot of people don't think about, grape seed, and also hemp seed, which is often promoted as this super healthy nut or seed because it has so much omega-3 and omega-6. Well, the problem is it's a bit high in the omega-6. So in a nutshell, just don't complicate it. Eat a little bit of everything, eat a variety, and don't overdo anything on this page. In a nutshell, did you get that? That's funny. Food number 7 is eggs, and we're talking about whole eggs. It's a very concentrated nutrient source for human cells. One of the main things it has is called choline, and we need choline to make what's called phosphatidylcholine, which is one of the main components of cell membranes. And we need the EPA, we need the DHA, we need cholesterol. But the next biggest component is phosphatidylcholine. Next, we need choline to make acetylcholine, which is a neurotransmitter. We need that for signaling, for muscle contraction, etc. We need choline for the liver to package up fat, to put the triglycerides into VLDL, these little transport vehicles. In order to assemble those, we need choline. And this is one of the main ways, this is a necessary way to get fat out of the liver and to reduce non-alcoholic fatty liver disease. In fact, they have found that virtually every case of fatty liver has a deficiency in choline. Eggs also contain something called lutein and zeaxanthin, which get specifically incorporated into brain tissue and into the retina. So it helps support retinal health, the eye health, visual health. And in doing that, it helps reduce the risk of macular degeneration. And this one hits close to home for me personally because my dad got macular degeneration. And that's basically what killed him, because once he couldn't see very well, he lost his central vision. He retained the peripheral vision for a while, but as his vision went, he couldn't watch TV, he couldn't read books, and over time, he just stopped being active. And when you stop being active, your body starts degenerating much, much faster. Eggs have often been quoted as having the highest protein value, the highest protein score of any food. So when you combine the yolk and the white, that's when you get the amino acids from both, and they complement each other, and they have this excellent, excellent protein value. So please, please don't separate the egg, the yolk from the white. And I cry inside every time I see this little package in the store with egg whites. It is such a waste. Food number 8 is fatty fish. And the best sources are sardines, mackerel, salmon, and herring. These have the best quality of fat, the largest amounts of omega-3s, the EPA and the DHA, and they're also very low in contamination, very low in mercury primarily. They are actually the richest sources of EPA and DHA that we know of. Eggs have some in it, and grass-fed beef have some in it, but these have values that are much, much higher. The EPA, it enters into pathways that signal about inflammation, so it helps reduce inflammation, and therefore it is often quoted as being the heart support. It helps reduce heart disease, because heart disease is basically an inflammatory disease. And then the DHA, the other component of omega-3s, gets the strongest concentration we have is in brain tissue and in the retina. As much as half of that retina is actually DHA. So when you're deficient in DHA, now your cell membranes, your brain, and your retina get deficient, and it changes a lot of signaling properties. So both of these are super important, and the DHA, especially when it comes to cell membrane fluidity, we talked about that also with choline, with signaling properties in general, with synaptic plasticity. So synapses are where nerve cells connect to each other, and they can start sending out new little threads, little roots, and connect. And that's how we adapt. That's how we learn. So synaptic plasticity is the ability to make new connections and adapt better. And like we said with the retina, it has some of the highest concentration of DHA. So DHA is also involved in visual processing. And if you can get a hold of wild caught fatty fish, the small fish like sardines are typically always wild caught, so that's good. But when it comes to salmon, then a lot of it, or most of it actually, is farm raised. And if you're in a restaurant and you don't have a choice, then farm raised is still going to be better than mac and cheese or hot dogs. But the wild is always going to have more of the good ingredients. It's going to have higher rates of DHA and EPA in it. Food number 9 is the organ foods, liver, heart, and kidney. And we can think of these as nature's multivitamin. They're some of the most nutrient-dense things that we can eat. Now, the liver, we have to point out that it eliminates toxins. A lot of people think that, oh, liver, that's the detox station, that's full of toxin. No, it eliminates them. It doesn't store toxins. And liver is very, very rich in vitamin B12, B9 or folate, in B2 or riboflavin, and B6. It also is very rich in iron, and specifically the heme iron, which is the bioavailable form, not like in spinach. This iron we can use right away. And it also has a good amount of CoQ10. Liver is the richest source of retinol that we know of, which is active vitamin A. And therefore, we have to also keep in mind that vitamin A can be toxic. So if you eat tons of liver, like every day, that's probably not a good idea because you can get too much even of a good thing. And then we have heart, which is very high in CoQ10 because it's the hardest working muscle in the body. So it needs all those mitochondria, all that CoQ10. It has like 3, 4, 5 times as much CoQ10 as liver, which is already significant. It also contains some proteins called collagen and elastin, which can be really important for us to rebuild connective tissue. And heart is also very rich in zinc, B12, and selenium. And then the third one, a lot of people don't really know about, but kidney has the most selenium of any food. Brazil nuts are super high, so you could eat just a couple of Brazil nuts a day and you get all of the selenium that you need and then some. But eating any more Brazil nuts than that can actually put you over the toxicity level. And kidney now has even more than that. So it's also something that you don't want to eat every day. And recently, a lot of people have discovered histamine intolerance. There's a lot of talk about it. A lot of people are suffering from it. Well, kidney contains what's called DOA enzyme that helps break down histamine. So this could be something that helps if you have a histamine sensitivity. And kidney also has about the same amount of B12 and B2 as liver, but it doesn't have the retinol, the vitamin A. So here's one that you could eat without getting the vitamin A toxicity, but then you also want to watch out for selenium toxicity. So again, just because a food is good doesn't mean you eat it every day. You eat it a couple of times a week maybe, or a few times a month. And food number 10 is beef, and especially grass-fed beef. If we can get it, that is better because it's just higher in all the good stuff. But when we talk about beef, we need to think about that we're getting 3 different things. And most people, when they talk about beef, they're just talking about the muscle meat, the lean meat. And we also need to think about fat, and we need to think about connective tissue, because this is what our ancestors did. This is what the native Indians did. They ate basically nose to tail. They consumed and took advantage of every part of the animal, and there's good reason to do that. With the muscle meat, those would be things like lean steak, like a fillet or a lean cut, or if you get a very low-fat ground beef. And here you are getting a lot of the things associated with meat. You're getting good value protein, you're getting creatine, you're getting carnitine, which is a nutrient that helps transport, critical for transporting fatty acids across the cell membrane so we can use the fats. It's very rich in zinc, B12, and the iron that we talked about. But we don't want to disregard the fat. And this has been lost in the fat phobia discussion of the last 50 years, that with the fat we get from fatty cuts, from eating beef tallow, and from taking advantage of the bone marrow. Now we're getting saturated fats, which is energy. We're getting monounsaturated fats, And people don't realize that. They just hear saturated fat when it comes to beef. Well, we have about half of in equal proportion, saturated and monounsaturated. We have about as much of each. Then it contains something called CLA, which is conjugated linoleic acid, which some people refer to as a bad thing because it's a trans fat, but it has nothing to do with the trans fats in margarine or hydrogenated products. This is actually like a super nutrient. It's an antioxidant, and it does us a lot of good. It's been clinically proven as an anti-cancer agent. And the fat also provides us cholesterol, which is an important precursor for many tissues and for different hormones, steroid hormones in the body, and also fat-soluble hormones A, D, and vitamin K2. But beef also can provide connective tissue, which has tremendous value, but we often miss out here because we just want to eat the tender steaks. But if we turn the bones into bone broth, if we eat oxtail, if we eat shank or some other tougher tissues that we need to slow cook, now we can break down that connective tissue, make it very, very tender, and we get the collagen and we get lots of other things to reconstruct our own tissues. So when we build bone, then we need this connective tissue. When we build cartilage, when we have tendons or ligaments, but also our gut lining needs these connective tissues. Our arterial walls, where we get damage from inflammation that contributes to heart disease, and also our skin. So all of these are connective tissue, and we want to think about this, that the different pieces of the meat, the different types of meat provide different things. And if we learn to cook and use all of it, we're getting so much more out of it. And there's also ample evidence that ruminants, which are cows, things that graze on grass and break that down, ruminant meat was something that our ancestors used as a foundational food. It's been one of the things that's created a foundation for tens of thousands or hundreds of thousands of years for humans. And I briefly want to emphasize what's not on the list. There is no grain, there's no seed oil, there's no sugar, and there is no processed food. And yet, that is the foundation of the food pyramid. This is what we've been told to eat for the last 50 years. But hopefully now you understand why we emphasize these two groups, that the animal food group is the best survival value. It's the densest nutrients for your human cells, and the vegetable group is where we get the fiber and the polyphenols to support our gut. Then we can still benefit from good fats, from fermented dairy, and some amount of berries and even fruit if we eat them seasonally and in moderation. But there's absolutely no reason to eat the base, the grain, the cereal that they have promoted as the foundation. Because all you find in that foundation is primarily calories. That's fuel. And it's not even a good fuel. Fat is our best fuel. It burns the cleanest, it burns the most stable, and the starches are basically just upsetting the system. So that base has very, very few necessary components. There's really nothing in there that we have to have. It's just calories. In fact, the starches and the blood sugar swings resulting will disrupt and make worse most of the important mechanisms that we have discussed here, that real food supports. And it doesn't necessarily mean that it's pure poison. It depends on where you are metabolically. So if you are insulin sensitive, now you can tolerate some of those starches. However, if you are insulin resistant, you need to realize that you are carbohydrate intolerant, and that group is not for you. If you enjoyed this video, you're going to love that one. And if you truly want to master health by understanding how the body really works, make sure you subscribe, hit that bell, and turn on all the notifications so you never miss a life-saving video.